So you've written your classic system.out.println hello world. You hit run and boom, it just works. But have you ever stopped to think about what's really happening inside the machine? Between that click and your program actually coming to life? Well, today we're going to pull back the curtain and dive deep into the nuts and bolts of how Java actually runs. Let's get into it.
It's a question pretty much every developer has at some point. You write the code, you hit the run button, and it feels a little bit like magic. But here's the thing. It's not magic. It's actually an incredibly brilliant piece of engineering. So how does that plain text file transform into a program that actually does something?
Okay, so let's start our journey with Java's most famous promise: write once, run anywhere. And honestly, this one idea is the key to understanding, well, pretty much everything about Java's design, and it solves a massive problem in software development.
All right, here's the first big mind-bending concept you got to wrap your head around. Your Java code doesn't run directly on your computer's operating system, whether that's Windows or a Mac. Instead, it runs inside this special protected bubble called the Java Virtual Machine, or the JVM. Think of the JVM as the secret sauce that makes it all possible. And yeah, this slide, it lays out the problem perfectly, right? On the left, you've got your single piece of code. But on the right, you have all these different systems: a Windows PC, a Mac, a Linux server, and at their core, they all speak slightly different languages. So how in the world do you bridge that gap without having to rewrite your code for every single one? Well, the answer is you use a translator. The JVM acts as this universal translator, sitting between your one Java program and whatever specific computer it happens to be on. It's literally the middleman that makes all this communication possible.
Okay, so if the JVM is our translator, what language is it actually translating from? Because it's not your Java source code. Nope. There's this super important intermediate step that creates a kind of universal language that any JVM on any machine can understand. And you can see the journey right here. Step 1, you write your code, the stuff a human can read, in a .java file. Step 2, you run the Java compiler on it. And step 3, it spits out a .class file. But, and this is the absolute key, that .class file isn't machine code. It's something else entirely. And that something else? That's what we call bytecode. This is the universal, platform-independent language we were just talking about. The bytecode inside that class file is going to be 100% identical, whether you compiled it on a Mac or a Windows PC. It's this universal bytecode that any JVM, no matter where it's running, is designed to understand. I love this analogy. It really clears things up when you hear about JDK, JRE, and JVM. Think of it all like a kitchen. The JDK, the development kit, is the full kitchen. It's got everything you need to invent and write brand new recipes. The JRE, the runtime environment, is more limited. It's just what you need to cook existing recipes. And the JVM, well, that's the stove. That's the part that does the actual cooking, the heavy lift.
All right, so we've got our bytecode and the JVM is ready to go. So now, let's actually step inside the machine and see how all the different departments get the job done.
First up, we meet the ClassLoader, and the best way to think about this guy is as the JVM super organized librarian. Before a single line of your code can run, the ClassLoader has to go find all the .class files your program needs, not just your code, but the core Java library stuff too, and load them all up into the JVM's memory. Without this librarian finding and loading everything, the whole operation isn't non-starter. Okay, so the librarian has loaded all our classes. Now they need a place to live and do their work, right? And you can think of the JVM's memory like a big, organized office building with different floors and departments, each with a very specific job to do. So the main floors in our office building are the heap, the stack, and the method area. Now, as a developer, the two you're going to hear about constantly are the heap and the stack. So let's zoom in on those two. First, let's talk about heap memory. This is like the huge open plan part of the office. Every single time your code uses the new keyword to create an object, new car or new user, that object gets its own little space right here in the heap. Basically, it's where all the things in your program live. All right, then we have the stack. Now, unlike the heap, which is this big shared space, the stack is more like a personal to-do list for each individual worker, or in Java, for each thread. It keeps a running tab of which methods are being called and holds all their local variables. And this is so important. Every thread gets its own private stack. That's a huge reason why Java is so good at handling multiple things at once.
Okay, so our code is loaded, the memory is all set up, now it's finally time to get some work done. And that is the job of what's called the execution engine, which has three main parts: an interpreter, a JIT compiler, and the garbage collector.
Now, the execution engine has this really clever two-part strategy. First, the interpreter just starts running your bytecode, one line at a time. It's simple, and it gets your program up and running fast. But at the same time, the just-in-time compiler, the JIT compiler, is in the background watching everything. It's looking for hotspots, pieces of code that run again and again, and it compiles just those parts into super, super fast native machine code. It's the best of both worlds. And last, but definitely not least, we have the unsung hero of the JVM, the garbage collector. Just think of it as an automatic cleaning crew for your program's memory. Every so often, it takes a look around the heap, finds any objects that aren't being used anymore, and just clears them out to free up space. And let me tell you, this is a massive feature. It saves developers from so many headaches. All right, we've looked at all the individual pieces of the puzzle, so now let's zoom out and put it all together. Let's trace the entire journey from start to finish.
And there you have it, the whole shebang, all in one place. You write the code, the compiler turns it into bytecode, the class loader loads it into memory, which is split up into the heap and stack, then the execution engine runs it, and you get your output. Seriously, every single Java program you ever run follows this exact same path.
Okay, I know that was a lot to digest, but hey, if you just remember these next 4 key points, you'll have a fantastic grasp of how Java really works under the hood. So here are the big 4. Number 1, the JVM is the whole reason Java is platform independent. It's the magic translator. Number 2, bytecode. That's the universal language that lets your program run on any of those JVMs. Number 3, memory. Remember the office building? Heap is for your objects, stack is for your method calls. And number 4, the garbage collector is your automatic memory manager. It's got your back.
So when you boil it all down, the most important thing to remember is this. The Java virtual machine isn't just some random piece of software. It's the incredibly sophisticated engine that's the translator, the librarian, and the office manager all rolled into one, making that famous promise, write once, run anywhere, a complete reality.
So there you have it. We've pulled back the curtain on how Java goes from simple text to a running program. It's not magic, just a series of brilliant logical steps. The question is, now that you've seen inside this machine, what other piece of tech magic should we break down next? Drop a comment and let us know. Thanks for tuning in.